So the first part that we're going to focus on for naming molecules is naming molecules for naming compounds. We're going to be naming molecules first. So a molecule is two or more nonmetals held together by a covalent bond. Held together by a covalent bond, right? So, nonmetals, your nonmetals aren't including all of your noble gases and these elements: carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, what is this one? Phosphorus, chlorine, beryllium, which is Se, bromine, iodine, and what is this one? Acetylene. Yes, acetylene. Okay. So again, to touch on it, just to make sure we understand, molecules are made of two or more nonmetals held together by a covalent bond, right? So, for our examples, for our first example number 1, we're going to start easy. We're going to start with CO2. Most of us do know the name of this already, but when we're naming our bonds, you take the name of the first bond, the name of the first element, which in this case is carbon. So we have carbon, and then if it was just one, we put monoxide. So 1, mono, 2, di, 3, tri, 4, tetra, I believe. 5 is penta, 6 is hexa, 7 is sorry, I thought I knew these by heart. 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Try to remember these because we might not always have a paper by us. But because now we know there are 2 oxygens, we put di, which is our prefix, and then ox, and then you take the ending of the word, which is oxygen, you take the ending off and you put IED at the end. So carbon di 2 oxide, carbon di, because there's 2 oxide. So that's our first example. We'll move on to our next example. So for our next example, we have phosphorus. We take the name of the first element. Sorry, I spelled that wrong. Phosphorus. Right? So we've done what we needed to with the first element. And now we know there are 3 chlorines. So 3 is tri. Sorry, I forgot the I there. Tri. And then we have chlorine. We take the ending off. Chloride. Add that IED. And that's our naming for our second element. We'll move on to our third. Now, for our third we are going to do C2F4, right? This one is a little more complicated, but don't be alarmed. You still name it just the same, even though there's a subscript of the first one. We do the same thing we would for the second one if the second one didn't have a subscript. So now we have di, because there's 2 carbon, so dicarbon. And then there's 4 fluorine, so we have tetra, right? Fluor, you take off fluorine and add your IED, fluoride, and that's our third example. So now we're going to move on to our slightly harder naming of compounds, which is our ions, which are all of our metals. So first thing we need to understand before we even get to naming is our positive ions are called cations, and our negative ions are called anions. correct? Yes. So, for each ionic bond, there are two components. The metal of the name of the metal ion. Because even though there's nonmetals, which are known as molecules, ionic means that a metal and a non-metal bond together. And that's what makes it ionic, because it's not two nonmetals. So the name of the metal ion goes first. And then the name of the non-metal ion, the non-metal, which is written last by using the first syllable of its element and adding "ide." So, again, non-metal, which is written using first syllable followed by "ide," which is kind of like what we did for our molecules. So now we're going to move on to some examples that'll make it easier. This one is only more complicated because there's math included in naming these. So we're going to move on to our first example. In our first example is sodium and sulfur. Now, sorry, I wrote that wrong. Don't get confused, don't get scared. This just shows our negative and positive ions. There's one positive, there's one positive cation and two negative anions, right? But the only thing is we have to cancel out these in order to rewrite this, right? We have to cancel out these ions, and I'll tell you why in a moment. So, going back to this particular thing is called ionization energy. The energy that it takes, which is known as the energy that it takes to remove a valence electron, right? So, we know that metals, in this case, that would be sodium, have between 1 and 3 valence electrons, right? Non-metals, sulfur, have between 5 and 7, and noble gases, which are complete octets, have 8 electrons, right? 8 valence electrons. So, this is important because in order to write our ionic bonds, we have to be able to cancel out these negative and positive cations and anions, because we have to. And so for positive ions, that means the loss of an electron. For negative ions, that's the gain of electrons. So the sodium will have to cancel out these negative 2 electrons, which means that there needs to be 2 positive sodium plus our negative sulfur, right? And this becomes Na2 and sulfur, right? This is our new ionic bond. After we've done the math, this is the easy part. This is where we name it. So we take the name of the metal, sodium, right? So we have sodium here, and then we take this one, which is sulfur. Sulfur has 2 syllables. Sulf is our first, sulf, and then we add IED instead of our second. So the name of this is sodium sulfide. And now we're going to move on to our second example. So for our second example, we have magnesium and we have nitrogen. So we can see that nitrogen has a positive because always nonmetals want to be positive and the metals are going to want to be negative. So we have 3 positive and 2 negative. So the best thing that we can do to cancel them out is to flip them. So this becomes magnesium with 3 and nitrogen becomes 2. And to name this, we take the metal's name, magnesium, and we take nitrogen, so we take nitro. This one is kind of hard because nitrogen, that's kind of 3, but we take nitra, and then we add IED, and that's the name for our magnesium nitride. So for our third example, we have lithium and nitrogen. So another way that I like to think of this is just balancing it, of course. So we have The way that we can cancel these out is we multiply 3 times 1 plus 1 times negative 3, and that cancels out to 0. So this means that we will now have 3 lithium and 1 nitrogen, right? And the name that we can make that is I believe it is trilithium. Or no, it's just lithium. Lithium nitride. And that's our third example for our ionic bonds.